Okay, namhlanje so YA pen, sorry. Okay, so today we'll be doing sorry, AC theory. Okay, AC theory. Okay, guys, the way we analyze a circuit that is supplied with direct current compared to a circuit that is supplied with a alternating current is not the same. But the laws that we been introduced to ekuqaleni, they do apply. Intoni? Ohm's law, Kirchhoff's law, which is Kirchhoff's current law, KCL, Kirchhoff's voltage law, KVL. Okay? Okay. So yabona now, our source is no longer the same as before. Yabo? Our source is alternating. Okay? Meaning which, okay, if I were to draw our DC source, yabo? There is a voltage versus time. You see that the voltage is what? Constant. The load is receiving a constant what? Meaning the load is receiving a constant voltage. But let's say now we have AC, a pure sinusoidal voltage. Okay. No? Okay. Let's say the peak is 5 volts. Okay, what I would when I demonstrate this, think of it as, but okay, EDC supply sisebenza full what? Full time. Full time you are receiving a constant voltage. AC is part timing. You know, it's not constant, they are part time. This one is what? Part time. Okay. About the difference between the two. This one is giving you a constant voltage of 5 volts, but this one is giving you a varying voltage, which is varying in magnitude, and is also varying in what direction. Okay, current flowing up, but it also varies in what magnitude. So, hence I was saying the way we analyze Indoni AC, so a circuit that are supplied with AC compared to circuits that are supplied with DC is not what the same, but the laws are still applicable. Yeah. So let us first understand the values associated with the what? AC voltage. If the voltage is sinusoidal, obviously the current will also what? Be what? Sinusoidal. That is at least according to what? Ohm's law, because if the voltage is increasing sinusoidally, it means the current must also be increasing. Okay, because if voltage increase, current increase. Okay, let me draw you a waveform. Okay, this is our sine wave. Okay, detail ngifuna uqale describe zonke values esizozisebenzisa apha, or because now with AC theory there is new terminology. This terminology is to describe this what wave, because it is not what constant. Okay, we don't need terminology with DC, because DC is constant, straightforward. Okay, nano try intoni peak value. Okay, is the maximum voltage or the maximum current. If it is it is a current versus what time. Okay, now the peak value. Guys, a peak value represent a capital letters apha. If voltage V max, or if we current body I max, look, I'm using a what? A capital letter. Okay. The next terminology we talk of in instantaneous value. Okay. Instantaneous value is any value chosen along this sinusoidal curve. Let's say it's voltage versus time. And the examiner wants you to calculate about what's the voltage after 3 seconds. Let's say 3 seconds. Well, that is an instantaneous value. What is the voltage after 11 seconds? Next example, 11 seconds, you find that. Okay, it's any value, any instantaneous, it's any value along what? The sine wave. That is instantaneous value. Then, enye into esinayo yintoni? I-RMS value. Okay? This one is important. Why is this one is important? This one is comparable to bani? To DC. Is comparable to idoni? To DC. How so? How so? This socket outlet, is it giving you a peak or RMS value? The socket outlet is giving you outati instrument, multimeter, test the voltage. That is RMS value. You only read a peak value on an oscilloscope. Multimeter, then RMS value. So, la 230 lo semaziyo, uV bani RMS. Ayingo-V ntoni peak. Suppose sine-source apha, the slide. The rating of this bulb ithi ifuna u-230 volts for it to glow. But our source is giving us 230 volts what peak in terms of AC. Okay. This bulb is not going to glow ngehlobo emele iglowe ngalo. because it is not receiving that money 230 constantly. This source is basically part timing. Yeah, okay. So so basically on average, the source is receiving, let's say, around 110 volts. Okay. But if we were to put 230 volts, what? DC. Let's say DC, na? If we were to put 200 volts DC, ibizogrowa kahle, ne? But if we put 230 volts peak, ayizolayita kahle because it's not receiving, on average, it's receiving 100 and what? 10, because this value is fluctuating, na? So how do we solve this problem? Okay. Dithe VRMS is comparable to bani? DC. So basically, for me, for this source to get u-230 continuously, i-peak yami ayimelanga ibe ngubani? 230. I-peak yami mele ibe ngubani? Let's say, as example, ngu-38. Then u-VRMS abe ngubani? Izoba ngubani? Izoba ngulo 230 bekumele itheni? Iyamfumana. Okay, that is what the root mean square value. It's a value that is comparable to what? UTC. Okay, what is the effect? Is basically the effective what? Value of this firing wave. Yeah, okay. Ngiyakhetha na? Then enye into esinayo yintoni? Okay, enye value esinayo yintoni? I-average. The most important value in this thing, in this chapter, is the RMS. Yabo? Average value is not really that important, but it helps us calculate into ezinjenge-peak factor, your into form factor and stuff, yonke loo nto, ne? Mhlawumbi ne-maximum voltage xa ubungayinikwanga. Yabo, it's not really important. The important value is the RMS value. Yabo, because we measure how much work is being done by the circuit by looking at intoni? RMS value. For example, when you are calculating the power, you use the RMS values. Okay. Average value of the voltage or intoni? Current is basically the average of the sine wave. What is the average? And that average is measured only on half a what? Half a cycle. If we were to measure average value on the complete cycle, mathematically average value ngangubani? Ingangu-0 mathematically. Okay, because this average will cancel that average. That is math, na? But the average value we are talking about, Tina as electrician, is only on what? Half a what? A cycle. Okay. Then enye into yintoni? It's a cycle. Okay. A cycle, ne? It's when a sine wave goes from positive peak, goes from 0, goes to positive peak, then it goes back to 0, then it goes to a negative peak, then it goes back to 1. Okay, that is positive and negative half wave, na? Okay, that will form a what? A cycle. So how many cycles do I have then? 1, no? A Y cycle pattern. 2, 3, then F4. Good. Uh-huh. Okay, that is a cycle. Okay, then spend on frequency. A frequency is the number of cycles completed per what? Per second. Okay, the number of these cycles completed in what? 1 second. And the unit is what? Hertz. Okay, which is cycles per second. Then okay, another quantity that is related to a frequency in period. Okay, period is a time taken to complete what? One cycle, and there is a relationship between frequency and period. That is an inverse relationship. Okay, meaning if the period increases, the frequency decreases. Yeah, because it takes longer to complete what? One cycle. Okay. Our standard frequency in this country is what? 50 hertz. If we were to drop the frequency, let's say drop it to 10 hertz, your incandescent, your light, you would see it what? Flickering what? On and what? On off. Yeah, bo? Basically, this button is always flickering on and off, but because that flickering is taking place at what? 50 times per what? Per second. Your brain cannot process or perceive but this bulb is what? Flickering. It will only perceive it, let's say, at what? 10 amps. Then you start to see, oh, this button is flickering. Yeah, bo? That means if frequency is low. Okay. Okay. Yabona importance of frequency. Yabo? If frequency is important to the operation of appliances. Yabo? If you take any appliance or any, let's say, a charger, a phone, a laptop, you'd see 50 hertz AC or 60 hertz AC. If it is not that frequency, other than that, that means this laptop charger won't operate properly because it is not designed for any frequency other than 50 hertz. Okay, now ke ngoku sesithethile nge-values zethu ne, let us write down the formulas that we'll be using, so at least now you know i-value nganye imele ntoni. Ithi ke ngoku the relationship between what? Instantaneous value and what? And maximum value. Yeah? You know, instantaneous value, I just defined it to you. You know, a maximum value, I just defined it to you. Okay? When you are writing instantaneous value, you use what? Small letter. Nah? The relationship, why am I using X? Is X is just to generalize generalize this formula, yeah, because this formula will apply on both what? Current and what? And voltage. Okay. And this entire course of electrical is based on what? On, let's say, is based on basically current, voltage, uh, resistance, and what? And power. Are you going to sit down in this entire course of electrical? I think nobody you can go ever say it. Always talk of a voltage, current, resistance, power. You know? That's the only thing is esitsho ngayo mbani. Yabo. I find a mechanical part of means melu yabo. Funa ngathi ngugqirha. Okay. Uh, okay. X max sin what? Theta. That's the relationship between the instantaneous value and what? Maximum value. Thank you. Let's see. But theta is the angle of rotation of the what? Conductor. Yeah, basically, apha sithetha yintoni? Nge-generator. Sithetha nge-voltage eproduced yintoni? I-generator. Generator must be a conductor that is spinning. So that is what the angles stand for theta. Okay. Sorry. Okay. Then moving on. But it's in what? Theta is in what? It's in degrees, nah? Okay. So if theta is theta must if it is given by what? 2 pi f t. We have to multiply by bani 57, comma, is it 57? Yes, 57, comma 3 to put it in, to put what? Theta in what? In degrees. Because sometimes you will be given a angular what? Velocity. Because load 2, ne? 2 pi f. 2 pi f is equals to, angular what? Velocity. Okay. Then, uphinde ube nala t. Basically, angular velocity times time, that is equals to bani? Angular what? Displacement. But it has to be in what? In degrees. We multiply by 1, 57, comma 3. Okay. So I learned this what the alternative formula. E max 2 pi f t. So when I have to multiply by what? 57, comma 3 to ensure that it's in degrees. Okay. Emax is instantaneous, is in small letter, nah? Okay, guys, basically what we've been doing so far, we haven't looked at any circuit either than we have been looking only at we are just analyzing our what? Source only. Yeah, We haven't looked at any circuit. We are just analyzing our car. Taking a load that is connected here. Sisafuna nje ngentoni? The source or the we are just learning about the nature of the source. You know? Uh, let us now advance our equation. Let us now advance our equation. What do I mean? Let us put it in what? Trigonometric what? Form. It's the same equation, but now we are writing it in what? Trigonometric what? Form. Okay. It says x plus or what? Or minus alpha. This is in what? Trigonometric form. Angular velocity must be measured in alpha, no? I'm gonna read it now. Okay. This is the proper way to put it on an AC source because it gives us many important values than as the yen. Because why Lena is important? Lena it gives us phase what? Shift. For alpha and what? A phase what? Measured in what? Radians. So we don't multiply Kobani or 57,3 here. Because that angle is measured in what? It's not measured in degrees. Okay. Yeah, one angular velocity times what? Time. How to? To radians. I prefer now you keep it in degrees. If I'm going from what? Radians to what? To degrees, I multiply by bani, comma, 3. If I'm going to what? Degrees. Yeah. For example, what they talk to is equals to 2 pi f. This is in what? Radians. Immediately, we know pi boy lo angle 10 equal radians. Because if value is a radians, it's no pi. Multiplied by what? 57, comma bani, 3 degrees. You get it in what? Degrees. Yeah, if you also have what degrees, 2 pi f the angle theta yena ukwi degrees akafani nalo simple ungubani ungu-alpha u-alpha yintoni u-alpha yi-phase shift u-theta yena yi-angle of rotation of the what conductor ikwi-radians yabo but xa usuka from degrees to radians udivide wabani 57 comma bani 3 then izoba kwintoni radian divide kausuka from degrees to radians kausuka from radians to degrees the reason I don't prefer you putting your calculator in in radians. Yeah, sometimes you forget that your calculator radians. Then also the calculation when the done for money ratings ezingekho right. Ube into yakho uyenze right, but ke ngoku i-calculator yakho is failing you because you forgot to change it from you forgot to change it back to what to decreases. Okay, the next topic is average and root mean square values of what AC waveforms. Okay, I said the most important value is the RMS value. Average value is not really that important to us. Yeah, because RMS value it helps us calculate the work that is performed by the circuit. Yeah, but it helps us to calculate the useful what? Power. Okay. Average is just there to help us get a maximum value or a form factor or a class factor. Okay. Let us write down the formulas. If you want to calculate a average value, let's say E average, it's not difficult to remember. 0,637 times what? Bunny? E max. Okay. But I cannot tell you myself at this level. And I figure at this level, but I know nende dibene ne-integration phakathi. Yabo, maths. But yabo, we are technicians, Tina. We are immersed in the world of practical. We don't care about theory that much. Yabo. Because ufuna ukwazi uba le nto ilungiswa njani. Yabo. Okay. Nabo abantu abazosibalela zonke ii-formulas. So thatha ii-formula zabo siziputhe into use uba le nto isipana njani. Ana? Okay. So nanso intoni? Then let's say sifuna intoni? RMS is what? 0,707. Guys, please. Upper we are only talking of what? Pure sine what? Sine wave. Why am I saying this? I don't want you to think every time when we deal with AC, we talk of a pure sine wave. Because practically speaking, there's no generator in the world that will give you a pure sine wave. Never. Never. Okay, this is theoretically speaking, we are saying the generator, this is the output of a theoretical generator is giving what? A pure sine wave. Yeah, okay, even though practically that is not the case because there are many effects in the real world. For example, at high school they used to say ignore drag or ignore friction, but practically it is there. You cannot ignore it. Okay, so these formulas are only for a pure sine wave. Okay, you will see when we get to N6 where we talk of non-sinusoidal waves. Guys, so I was telling harmonics. Okay. A pitch factor, it is always 1,11. Okay. The only thing enosinika a pure sine wave, khona into ekuthiwa yintoni? I-function generator. Okay. Generator. It is not a typical generator. It is an electronic device. Yabo? I-electronic producer a sine wave electronically, not having a armature and field winding rotating. It produces it what? Electronically. So there's no AC machine that gives a what? A pure sine wave. Yabo? Okay. So pitch factor is always what? 1.1. Should you calculate the pitch factor and not get 1.1, that is not a what? A pure sine wave. Yabo? Pitch factor will indicate to us, okay, this is a pure sine wave. Nobe value ngangobani, we should always get a pitch factor ingubani. At at this level, we are only talking of pure sine wave. Pitch factor is the ratio of the RMS to the average. Because if you notice, I don't a common part between these two. Max, siyathini? Siyacancelishana kasithini? Divide. So basically, we are always dividing 0.637 by 0.707. Okay. Then sibe nento ekuthiwa yintoni? Cross factor. Cross factor yona it is always what? 1,414. Okay, these things, pitch factor and cross factor, they are mostly important kwi-electronics. I don't know whether I'm mistaken, but you would find that a pitch factor, there's example, a pitch factor ye-square wave, mhlawumbe ngu-1, yabo, it is used mainly in electronics, these two values, yabo, to to know, so that the technician knows what type of wave are they dealing with. Yabo? Okay. Look, the non-sinusoidal wave is any waveform that is not a what? A sine wave, and is also not sine-like. Yabo? But up again, we are talking of sine waves. Okay. Up. It is determining the average and what? Oh, apparently, okay, you are introduced to sine waves, even about N5, but it's just an introduction. Okay, determining the what? Average value and what? RMS value of a what? Non-sinusoidal right? Wave. Yeah, for a pure sine wave, doesn't change. Yeah, for a non-sinusoidal sine wave, this is how we calculate it, the average value. This is for what? Non-sine wave. Okay. Aba-E bancinci sibabiza ngentoni? Okay. Meet what? What is nice about N5 is that you don't have to use a roller like N4. N4 they had to use a roller and stuff to do all this thing. We'll measure it. You just take two values ozinikiweyo, then you add them, then you divide them by 2. Ikunike ntoni? I-mid ordinate. By N4 they do that using your ruler, ne? So basically you have to draw yonke into oyidrawayo, you draw according to what? Scale. Apha you just can calculate it, no? Which is more accurate than using the ruler. Okay, then the next thing, is for the RMS, the same formula. Or RMS, same thing there, but you square the mid ordinates, na? N kuba zingaphi mid ordinates zakho? If ziyi-5 as the values uzethe phaa phezulu, divide by 5 N law. Okay. E1 squared plus E2 squared plus E3 squared plus guys, what theta no alpha, these are not what? The same. What theta is telling the angle of conductor in degrees, yes. Then I don't phase what? Phase angle or phase shift, yes. Okay. Phase what? Shift. What is the phase shift? Let's say this is voltage. Okay. Let's say this is 0. This is what? This is 90. This is 1 bunny. 80. This is bunny. 270. This is what? Okay. Let's talk of a current and voltage in phase. Okay, if they are in phase, yabona zoe two, they begin at the same time at 0. They get to a maximum at the same what? Same time. Yeah. They go back to 0 at the what? Same time. They go back to they go to a maximum in the opposite direction at the what? Zihamba ixesha eliyi-1 zingaphi? Ziyi-2. Okay? No? Okay. Let us say the current is leading a voltage by 90 degrees. Yabo? So let's start up again. Yeah. Yes. What is the phase angle there? The phase angle is 90 degrees. The phase shift is 90 degrees. Meaning the current is ahead of the voltage by 90. or it can be behind by what? 90. Okay. So can you draw yonke this pattern? Yabo? Can you draw yonke this pattern? At 0 already yona intoni? The current is at what? Maximum. It's leading. It's leading what? The voltage. Yabo? But we haven't talked about why that is happening. That is based on a property of a capacitor and what? And inductor. Because a resistance, a voltage, and current are in what? In phase. Because remember, the inductor opposes in only current. Change in what? Current. You know? That is why the current is lagging what? The voltage. Okay? But when it comes to a capacitor, when you first put electricity on it, the voltage is what? 0. And the current is what? Maximum. Okay? Why is that? It's because capacitor, it behave as a short circuit because as a plate is empty. So electrons zonke ziyarasha uyofilisha eza plates. So you have an instant uthi usalayita nje ube ne-current enjani eninzi, then ibe i-voltage ngubani u-0, yabo, because into kayi-conductor at what, at low resistance, i-voltage iba closer to bani, to u-0, if it is conducting at what, low resistance, because remember voltage times what, voltage times I times one resistance. If the resistance is very, very small, what does that mean about the voltage across? Small. If you take a multimeter and measure and put a circuit and measure a voltage across wires ne resistance engakanani encane. Hence, if voltage is ngakanani across them, if voltage drop is low. So if it is conducting with low resistance, there is high current, low what? Low voltage. Yeah, so capacitor behaves as a short when you first apply on electricity because the plates are what? Are empty. Remains practical mas training. And that means okay. Wawumenzile na? Wawubona mas kawuthatha i-multimeter uyikonekta kwi-capacitor. Iyayiqale iride i-resistance encinci. Then over time ithini ibuyele kubani? Ku-overload or infinity. Wayilibala ne? Okay. Hayi nayibona kodwa. Fine. But it won't affect what we are doing here. Yabo. I'm only showing you uba yintoni? Yintoni? I-phase what? Phase angle or phase shift. Okay. I-sinusoidal wave, guys, you will see it can be represented by a vector. A line with a what? Arrow. Okay. The longer the line, that means we have it has a high value, high magnitude. Okay. Then it up an alternating current is represented by the equation. That is a what? Trigonometric what? Form, na? Na? It's in a what? Trigonometric form. Okay. It determines the following, the value of what? The value of the current. The value of the maximum, the maximum value of this current. What is the maximum value? 224, bani? 8. According to standard form. 24,8 maximum current. Then the phase shift in what? In degrees. Bayifuna in what? In degrees. Yabona ngoku ikwintoni? Ikwi-radians. So you multiply it by what? I-phase shift bani? La 2 yong la pi over bani? Over 3. Yes. Ithi enye average value of what? This current. Here's average value of a pure sine wave is given by 0,637 times I max. Anna? Not yet. Since what says cover, check out. Yeah. But we can corner, but it would be time wasting now because this thing, this section where we are only looking at the what? Supply side is straightforward. Zoyibona nawe noba ingabuzwa question paper, this thing is straightforward because as long as you understand the upper and you understand i-formulas, yabo, by i-formula. For example, i-frequency singayibala njani pha? Yabo laa ndawo inobani? 471, koma bani? 329. Laa part leya bekusuppose khona ntoni? 2 pi f. So iyaqonda uba ungasebenzisa le value to find ntoni? I-frequency. What is this value according to a standard form? That is angular what? Angular velocity. That is angular velocity. If you look at a standard form sakho, W, angular velocity in radians per what? Per second. The formulas. Yayazi uba each value imele ntoni. And it's in a trigonometric what? Form because kufakwe ntoni? U-plus, minus. La plus minus iyasibonisa uba i-trigonometric what? Form. Okay. Because kwezinye equation asinayo la plus minus. We only have 2 pi ft. Okay, of which is we're going to have to multiply by 57,3. Anna? Or we have angular velocity times what? Time. Anna? Then you're going to have to multiply it by 57,3. Yeah, it is the effective value non RMS value. RMS value, your pure sine wave is 0,707 times what? Imax. Imax, you look at the standard formula. Imax man 24,8. Then times our 0,70. I go straightforward. No? Okay. Then if we need one, period man, T. Anna? A period is what? I'm what? Sorry, I'm making a mistake. A period, that is not the period. Okay. A period, ifumana yintoni? A frequency. Remember, a period is related to yintoni? A frequency. F 1 over bani? Over T. So uzoqala ucalculate yintoni? Frequency. Then uthi T is equals to 1 over F. Sorry, making a mistake. Uthi basically lixesha after to help us find instantaneous what? Current or instantaneous voltage. Okay. It's not the time. It's not the time that is required to complete a cycle. It's the time oyixelelwayo uba okay, kosibalele cela usibalele i-value of this EMF or of this current after 2 milliseconds. Mhlawumbi izoba lapha instantaneous value. It helps us calculate instantaneous value. It's not the time taken to complete a what? A cycle. Period length. Okay, what difference between uT and one? Period. Longitude. The instantaneous value of the current 4,2 milliseconds after the beginning of the cycle. Yeah, okay, ayo period. Then the time it takes for the current to reach money 13,6 amps during the first half cycle, meaning bafuna uT lo mncinci ke ngoku. Uba what time does it take to reach money? This value. Let's say this value. What is the time? Yabo? Okay. Then we have a non-sinusoidal what? Current there. Okay. We have a what? A non-sinusoidal current. We are given intoni? I-ordinates. I-ordinates azifani nantoni? Ne? Mid-ordinates. Okay, but we use i-ordinates to get what? Mid-ordinate. Laa nto ebendithetha ngayo. So if besifuna mid-ordinate, besizothi 0 plus, for example, ezi zokuqala ziyi-2. Sifuna i-mid-ordinate yethu yokuqala ye-current. Anda? Okay. Iyana? Sifuna the first mid-ordinate. So bani? 0 plus 6 comma bani? 9 divided by bani? By 2. U-0 nala 6,9 yintoni? I-ordinate. Thina sidinga intoni? I-mid-ordinate in order to calculate intoni? I-RMS or intoni? I-average value of a non-sine wave. Okay? Then i-mid-ordinate yesibini would be 6, bani? 9 plus bani? 11, 1 divided by bani? By 2. And so on, so on and so on. Then as I made ordinate, you use it when you want to find intoni? RMS value or intoni? Average what? Value. Okay. Now we are done with looking up. We are done about talking about the nature of what? The supply. Let us talk of intoni? EAC intoni? Circuits. Okay. Let us talk of intoni? AC circuits. Yeah, but the first session is very easy now. So if you put me there, you should get it your own. Okay. i-components esinazo ne embaneni embaneni. Okay, I want before starting ngaloo nto, no. Let us first talk about intoni? A vector what? Diagrams. Guys, abantu they fail techniques because of this thing. They don't understand their vector diagrams. Never. Gonna have a problem if you don't understand a vector diagram. Because a vector diagram simplifies these calculations we'll be doing now. Because you find that to solve a problem, you have to first draw a vector diagram. Remember why vector diagrams? The AC has a what? A magnitude and a what? And a direction. So it can be represented by a vector. Okay. So with vector diagram, when you're looking at the vector diagram, the first thing you should know is which one is my reference. Okay? Okay? You're the one who's gonna choose my AP reference, yeah. Or the examiner will choose which one should you take as what? Yeah, as reference. But normally, a reference is always taken as a voltage. Normal, standard. Take a voltage as a reference. And I want you to grab this is a clockwise rotation is a what? Negative angle. Nah? Taking a voltage as a reference, standard. Nah? Then a anti-clockwise rotation is a what? Positive what? Angle. Okay. So I don't want to go deeper again in terms of explaining as this thing. Nah? What do I mean? In an inductive, what? Your mankala in a resistive circuit. Okay? You mean if I would explain about okay why kunjena. Okay, in a resistive circuit, if voltage, there it is. It is my reference. Okay? Yeah? If voltage and current are in what? Phase. No? There's no phase, the phase shift or the phase angle between them is zero. Okay? Banthetha ngolink. Yabo? The current is in phase with what? The voltage when you analyze this by looking at it. Yabo, I'm referencing to what? The voltage. Where am I referring to? I'm referring to the voltage. No? That is in a resistive what? Circuit. Into obusoloko ixelelwa loo nto ne uthi uyiqhenyise kuthiwa andazi kuthiwa yintoni ngucivil laa nto bakunika yona uba if ubambe ucivil you'll be able to know yabo i-strategy sort of more like usoccer tower xa ufuna ukwazi yabo ungalibali. Then let's talk of guys lagging ne lagging is what? Negative. Angle. Okay. When we're saying lagging, the angle is what? Negative. When you say leading, the angle is what? Positive. Okay. So this is in a pure what? Resistive what? Circuit. It's a corner pure resistive circuit. Your incandescent bulbs. Name heater. Your heater elements. Those are purely resistive loads. So they call them. Then also be inductive what? But in practice, practical speaking, I circuit that is purely what? Resistive. Yeah, think of this cable. This cable should be what? Purely resistive. But ka ndiyibeka le cable ndingayibeka ihlale noba kanjani. Yabo. Am I not forming a what? An inductor kanjani? Because the inductor wire that is coiled. Because the cable must then igoqe ndithini isheke ihlale ila shape. So it's not gonna be purely resistive. It's gonna develop a certain amount of inductance because of that. Because ayikho wire ehlale straight kanje. Anna? Practically speaking. Anna? Okay. Practically speaking, le wire mhlawumbi ngathi kanti ayihlelanga yodwa ihleli nenye iwire esecango kwayo. Yintoni le? Capacitance. Two wires separated by what? Insulator. Yabo, xa zirana kulaa pipe ayirani yodwa, irana ihlohlwe nezinye ii-wires. So ayikho into ekuthiwa yintoni? Purely resistive circuit. Yabo? Practical. Yabo? Yonke into will serve a certain amount of capacitance or a certain amount of inductance. We call them stray capacitance or stray inductance. Yabo? Then in a pure inductive what? Circuit. Let me draw my reference phasor, which is what? The voltage first. Anna? The current in a pure inductive circuit, the current lags what? The voltage by what? 90 degrees. That is a pure what? Inductive what? Circuit. So, banqale kwintoni? Kwi-reference phasor yam. Ndizorotate 90 degrees. Upho 90 degrees nanku. Okay? That is a what? Pure inductive circuit. Okay, there's no such thing as a pure inductive circuit. Even the inductor is what? Inductor yenziwe ngentoni? Ngentambo, ne? Intambo ayina resistance? No. So you have a combination of a resistance and inductive reactance. So that is not pure inductive. Hence, you don't find the angle engubani engu-90. Yabo. But we only get a phase shift engu-90 by only assuming that is purely inductive. Then angle negative bani 90. Yabo. Okay. Then let's talk of a capacitive what? Give circuit. In a capacitive circuit, let me draw the phasor first. The reference phasor I am done. The voltage. The current leads what? The voltage by what? 90. Detail leading angle, positive angle. And positive angle means we rotate anti what? Clockwise. About how we analyze it, a vector what? Diagrams. We're gonna analyze the one that is on the board. We're gonna analyze this one that is on the. Please don't look at the paper, please. A reference yami lapha ne. A reference vector yami voltage. Let us describe this vector diagram. Masiqale I1 versus a reference, which is the voltage. Yeah, but for me, I'm at my reference. For me to get to I1, I have to rotate what? Anti-clockwise, meaning that angle is positive what? 30. The angle between ubani, I1 nobani, no V, ubani, positive what? 30. Positive angle, that is what? Leading. So we can say I1 leads ubani, a voltage by bani. Let us look at I2. Looking at I2, here is my reference vector, which is the voltage. Okay. For me to go from the reference to I2, I have to rotate what? Clockwise. Ne? Clockwise rotation, negative angle. Basically, the phase angle is what? Negative 30, which is lagging. So what statement do I make? I say current I2 lags by voltage by 30 degrees. Sanamna. Okay. Then current I3, they're in the same line. Is in the same line as a reference. So I say I3 is in what? In phase with the voltage. That's how you analyze, and that's how you draw up in a vector diagram. Oh, okay. Ngiyabona kahle. Okay, guys, let us continue tomorrow. Ne? Yeah. Then tomorrow we'll cover all the AC what? Circuit. AC circuit, where a circuit where you have only a resistor, circuit where you only have capacitor, or where you have a combination of them, whether in series or in what? in parallel. That is gonna be simple, but you'll see when I explain it tomorrow. So beno suku omnandi, but so far